Alright, trig pre-calc, we're on to chapter 11, skipping over 10, getting right after the test. So in this one, we're talking about parametric equations. I left that front page for y'all to kind of decipher and make sense of yourselves. But this definition box right here, I'm going to go over real quick because there's a lot of new variables that we're setting and a lot of new terminology that we're going to cover. So, first thing I want to talk about is f and g are continuous functions on t, or of t on an interval I. So f and g, first of all, are continuous functions, which means that basically you can plug in anything for x. A discrete function would be the opposite, in which a discrete function would be like how many people can you get into an amusement park, whereas, and you can only have a whole amount of people, right? So you can't have like 2.5. But a continuous function includes decimals and everything in between two whole numbers. So continuous functions of t, so that means that their variable is t, so it's not x and y. It would be f of t and g of t on an interval I. So that means we're going to be working with intervals. Pretty easy to remember that I stands for interval. The set of ordered pairs f of t, g of t is a plane curve C. So C is going to be plane curves. I is going to be our interval. F of g, F of t, g of t are our functions. So these equations, x equals f of t and y equals g of t, are parametric equations for C, so for the plane curve, and t is the parameter. So it's important to know that t is the parameter, that's the variable we're using, and that's why it's called parametric equations. And this is how we would write one equation out, separating it into two different things. And so this would be useful because if we're talking about something like this curve, right, or throwing something off a cliff, not only does, or we could say that the ball moves in this direction, right, or whatever we're throwing, or we could say that the ball moves in this direction at some certain rate, and it also moves at this direction in some certain rate, right? And so what a parametric equation does is takes the movement in this direction and this direction, makes those their own separate equations based on one common variable, which is usually t for time, and that's how we represent the equation instead. So that's what we're going to be doing with parametric equations, and I'm going to go over this example right here real quick, and then hopefully we'll see how we're doing from there. So I really wish they gave me a coordinate plane on these notes, but I'll try and make one right here. So I'm going to do this problem, but I'm just going to do the work up here so it's easier for me to write and for you to see. So if we're going to sketch a curve, it's probably a good idea to get some points, right? And the good way to get some points, an easy way to get some points, not test points, but points on a graph, would be to make a table. And if we have not just two variables now, but three, our t-chart is going to look a little different. So we've got our new kind of chart, and in this row, or in this column we'll have t, in this column we'll have x, and in this column we'll have y. And we'll get about 5 data points. And so if we have our parametric equations right here, t is going to be our parameter. Here's our interval. So we're trying to find the plane curve given by these parametric equations. So what we can do is plug in these numbers for t. So we'll start with -2. I want to go -1, 0, 1, 2. Looks like I got to add one more row. That is a-okay. Just might get a little tight. So it's important that you get all of the data points on there, not 5, I'm sorry. 5 isn't a magic number. It depends how many numbers are in the interval. So let's go ahead and just plug these in to our parametric equations to figure out the patterns moving in the x-axis and the patterns moving in the y-axis. So if we plug in -2 to the x equation, we get -2 squared minus 4. That's 4 minus 4. X would be 0. How about -1 squared? -1 squared, 1 minus 4, -3. 0 squared minus 4, -4. 1 squared minus 4, -3. 2 squared minus 4, 0. And 3 squared minus 4 is 5. So we will write those in just a second. And then for our y values, we plug in y to this equation. We got y equals t over 2. -2 over 2 is -1. -1 over 2 is -1, or -1/2, right? 0 over 2, 0. And I got 1/2, 1, 1.5. So now we're just going to go ahead and graph these points that we got on the x and y axis. So we'll go x and y. We only need a couple dashes. And then for x, we got a couple more. So now once we go ahead and graph these points onto the graph, or onto the coordinate plane, we will have gotten the plane curve given by these parametric equations. So our first point is 0, -1. So 0, -1, got a point here. Actually, I'll try to use a different color. Got a point here. -3, -1/2, so I got a point about here. -4, 0. -3, +1/2. So we're going back that way. 1, or 0, 1. And then 5 goes to 1.5. So that'd be 1, 2, 3, 4, 5, up to 1.5. And so our curve is going to look like this. Which is a little funky because we know that this doesn't pass the vertical line test. But just knowing that this can happen is useful because we might see that in the future. So that's video number 1 for chapter 11, parametric equations. Hopefully you can at least understand this process and the tasks that we're going to be asked to do. And we will go into more depth about the rest of the sections in a second.